All right, the back of the book will probably factor out a 3 from here, or a 2, I mean. I kept saying a 3. A 2. So if you factor a 2 out of here, you'd have a 2 over 30 times 2x plus 1 to the 3 halves. And then a 2 pulled out of here would be 3x minus 1 plus c. So that final answer would be 1 over 15, or 2x plus 1 to the 3 halves times 3x minus 1 over 15 plus c. So if you are doing these problems and you get to here, where were we? Here, and then you look in the back of the book and they have this, don't panic. Or even if you get to here, sorry, this black one, and you look in the back of the book and you see this, don't panic. You have the same answer, but they just did some more factoring and simplifying. Be sure you are able to get to this answer. So I would practice getting from here to here to make sure that you have it right. And in the case of multiple choice questions, the multiple choice answer might look like this. And you might get to here and be confused, well, I don't know which one to choose if you haven't been practicing this simplifying all along. But on a free response question, it's perfectly fine to leave it like this. Okay? In this case, we look like we have a product. We can't distribute this in, so we're going to choose u. U is 2 minus x. That's the one that's inside of a square root. Now I know that this one has a higher power technically, but usually the square root is the more difficult of the factors in our what looks like our product rule to deal with. So I would always choose what's inside of a square root over anything to any other power. Take the derivative. That's going to be negative 1. Solve for dx, which means multiply both sides by dx, divide both sides by negative 1. Du divided by negative 1 is going to be negative du. So now that's what we're going to substitute. We have the integral of x plus 1 times the square root of u, and then dx is negative du. Notice at this point we still have an x. If you still have an x here, you've got to do that additional step. Solve u for x. So what I would do is add x to both sides and subtract u. So then you get x equals 2 minus u. So if you get to this step and you've substituted everything in, you can, and you still have an x, you must go back to u, solve it for x, and then substitute that in. So we're going to have the integral of x plus 1, and in this case our x is 2 minus u, times the square root of u, times negative du. So now we have only the letter u left. Let's simplify that. Integral of 2 minus u plus 1 simplifies to 3 minus u. Square root of u can simplify or be rewritten as u to the 1/2. A negative can come out in front. Remember, you multiply or divide by any constant and you can pull that out in front, not adding or subtracting. You cannot pull any x's out either. Never pull an x out of an integral. Only constants that are being multiplied can come out of the integral. Okay, now we're still simplifying here. Distribute that in. So we'll have 3u to the 1/2 minus u to the 3 halves du. Now we can integrate. So the antiderivative of 3u to the 1/2 is 3 times, add 1 to the exponent, divide by the new exponent, minus u to the 1/2, u to the 3 halves, adding 1 to the exponent becomes 5 halves. Dividing by 5 halves is the same as multiplying by 2/5. And that's plus c. Brackets are for that negative that's going to be distributed in there. Okay, we can do a little bit of canceling here. And we can factor right now, because we want to factor just like the book does, right? So pull the 2's out, so we'll have a negative 2. U to the 3 halves, u to the 5 halves. What can we pull out? We can pull out u to the 3/2. What's left from this then, if I pull out the u to the 3/2, is just 2 minus, oh, I already pulled the 2 out, pardon me. So that would just be 1. Don't forget, you have to leave something there. So I already pulled the 2 out, and I pulled out the u to the 3/2, so there's nothing left from that except a 1. This one, the 2 is out. I still have the 5 in the denominator, and u to the 3/2 pulled out of here leaves me u to the 2/2, which is u to the 1st. Thinking the book's not going to like this fraction, so multiply this by 5/5 and pull out the 1/5. So it's negative 2/5 u to the 3/2 times 5 minus u plus c. Is that done? Nope. We started with x, we've got to finish with x. So now, back substitute. So we have u, which is 2 minus x, to the 3/2, times 5 minus u, so 5 minus 2 minus a negative x, and then plus c. So our final answer, negative 2/5 times the quantity 2 minus x to the 3/2 times the quantity 3 plus x plus c. Final example, write an equation for a function f that has the indicated derivative and whose graph passes through the given point. So this is our x value, and this is the y value on the original f of x graph. But we have the derivative. Another way to write the derivative is dy dx. If we want to get to the original function, we're going to have to do the antiderivative. So multiply both sides by dx to separate your variables, and then we can integrate both sides. So we've got the integral of each side. The integral of dy is y plus c, but we'll combine our c's at the end. This integrand looks big, scary. What are we going to use for u? Could we use all of secant? Well, the derivative of secant is secant tangent. So if this is u, we don't have secant tangent left there. Could we use all of this? What's the derivative of tangent? The derivative of tangent is secant squared. We only have secant here, so all that's not going to cancel out. What if we choose u as the innermost function, which is pi x? Pi x is inside of secant and tangent. Take the derivative. That's pi. Multiply both sides by dx. Du equals pi dx. Solve for dx by dividing by pi. So dx equals du over pi. Let's substitute. So we've got the integral of pi times secant of u times tangent of u times du over pi. Simplify. Anything cancel? Yep, the constants cancel. So now I just have the integral of secant u tangent u du. At least all the variables are gone, all the x's I mean, so I don't have to do my special step 3b. But what's the integral of secant u tangent u? We still seem to have a product, right? But remember, the integral of secant u tangent u, that's actually one of our derivative formulas. If this integral of secant u tangent u, it's asking you for what has the derivative of this answer. What is this the derivative of? And that's the derivative of secant u plus c. So don't forget your basic rules. This is the original function. We take its derivative. That should be the answer for the derivative. When you integrate, you're integrating the derivative to get back to the original function. All right, that's plus c. We know x and y, but that's not x, is it? This is x, and that's not x. So we cannot put 1/3 in here. Remember to back substitute to the original function and then plug in your values. Y is 1, x is 1/3, so pi times 1/3 plus c. Pi times 1/3 is pi over 3. What's secant of pi over 3? Well, that's the same as 1 over cosine of pi over 3. Unit circle, pi over 3 is the 60-degree angle. Cosine is the x value, so it's the short side of the 60-degree angle. Triangle, which is 1/2. 1 over 1/2 is 2. So 1 equals 2 plus c. So c equals, subtracting 2 on both sides, -1. So our function, going back to this step, but now we know c, secant pi x plus c, which is -1. So this is your final answer. Homework, page 306, 47 to 105, every other odd. So you're going 47, 51, 55, etc. up to 105. Then 107, 115, 119, 123, and 129.